In this lesson, we're going to talk about the domain and range of a different kind of function now, what we call a discrete function. So let's imagine that we're ordering pizzas for a class party, and we're going to, order a certain number of people, and each pizza costs $12. So let's label the independent and the dependent variable. Well, I know that the total cost is going to depend on how many pizzas that I order. So my independent is going to be the number of pizzas because we know that zero pizzas cost $0. One pizza would cost $12, and so on and so forth. So then my dependent variable would be the cost of the pizzas, right? So now the next question here says, should we connect these points? Why or why not? So when we're connecting, right, we would say that all of these points in between the dots are on the graph too. So 1.5, 5 could be like a point. But if we think about it, could we order half a pizza? Well, no, right? Well, you have to order a whole pizza, right? So in this case, no, we are not going to connect these points because you cannot order partial pizzas. Okay, you cannot order partial pizzas. So if we don't want to connect the line, if we don't want to connect the points with a line, we call this a discrete function, right? A discrete function is a function that is not connected by a line. And it just kind of depends on the situation. So you have to think and use your judgment, like, would it make sense to have partial amount of something? And we can write the domain and range of discrete functions as well. All we're going to do for the domain is write all of the x values. And for the range, we're going to write all of the y values. Okay, so let's look at what we do here. So for this first example here, we want to write the domain and range. I'm going to use these squiggly brackets, which we call sets. And so I'm going to just look across my x-axis here and see where are all of my points located. Well, I've got one here, I've got one here, here, and here, making notes on the x-axis. So this is -1, 2. So this is -3, -2, -1, and this would be +2. So I'm just going from left to right. My values are -3, -2, -1, and 2, and that would be my domain. My range, the same thing. This time we're just looking for all of the y values. So I've got one here at -3, here at -2. Right here on the y-axis, I would be at 0. And all the way up here, I would be at +4. So I've got -3, -2, 0, and +4, and then close my set like that. This time my domain, let's make my set again. My first point is right here at -4. My second one here on the x-axis, since it's on that y line, is 0. And this one would be +3. So going from left to right, or smallest to greatest, I've got -4, 0, 3. And now for my range, I start again with the set. Right here on the y-axis, this is equal to 1. And now I see that both of these points are on the same line here, and that y value is 1, 2, 3. Since both of those points are on the same line, we only need to write it once. So I can do 1 and 3, and I can go ahead and close my set like that. So let's look at another real world situation. So Paul paid $6 to enter a pumpkin patch so he could buy pumpkins for $2 each. He wants to buy at least one pumpkin, but not more than 4. And so it's making a function based on how much all of his pumpkins cost. So we want to know first, is this discrete or continuous? Well, I need to think, could I buy part of a pumpkin? Probably not. That'd probably be a pretty bad deal. So this is going to be discrete because we cannot buy partial pumpkins. Okay, we cannot buy partial pumpkins, so this has got to be a discrete, which means we wouldn't connect it on the graph. So what are the independent and dependent variables? Well, if we're measuring the cost, that's going to depend on the number of pumpkins that he buys. So my independent would be his number of pumpkins, and his dependent would be the total cost. So let's kind of map this out on this table here. So we know he wants to buy at least one, but no more than 4. So that would be, he could buy 1 pumpkin, 2 pumpkins, 3 pumpkins, or 4 pumpkins, okay? Because he's not going to go above that. And so now we also know that there's $2 each, but he also paid $6 to get in. So if he buys 1 pumpkin, he paid that 6 plus that additional $2 for a total of $8. If he buys 2, well, that's 2 more dollars to give me 10, 12, and 14. So now we want to know what's the domain. Remember, domain is all of my x values here. It's all of my independent variables. So my domain is just 1, 2, 3, and 4. And same for my range. It's all of my dependent variables, which is all of my y values, which in this case is just 8, 10, 12, and 14. And that's how you find the domain and range of discrete functions. I hope you had as much fun as I did. Good luck in your practice, and I'll see you in the next video.